In this video, we are going to discuss three-dimensional figures. The three-dimensional figures that we are going to look at mostly involve what are called prisms and pyramids. These are just two examples of the types of three-dimensional figures that we are going to be studying in this section. When you are talking about a three-dimensional figure, naming it and finding volume and surface area, which we will be doing in the next few days, it is very important that you know which parts of the three-dimensional figure are which. So if you look at this prism on the left here, you'll see that this is a hexagon. That is called the base of the figure, and there is another base up at the top. The vertex is going to be the corner, any corner of the prism. An edge is going to be just like that, and then a face is going to be this rectangular side here. And there's going to be faces, they go all around the prism. Similar with a pyramid, except that there is only one base, and the faces of the pyramids are not rectangles, they are triangles because they meet at a point, the apex at the top. But they also go around the outside of the pyramids. When you name a three-dimensional figure, you name it by the shape of its base and the shape of its faces. So the base of any three-dimensional figure could be any polygon. A triangle, a square, a rectangle, a trapezoid, a pentagon, a hexagon, an octagon, a decagon, etc. So first thing you have to do is identify what shape is the base or the bases, and then you want to look at what shape the faces are. So if the faces are rectangles, that shape is a prism, and if the faces are triangles, then we know that is a pyramid. So when we are naming our figures, that is how we come up with our name. So let's see if we can name some three-dimensional figures. If you had trouble with those, one thing to be careful of is that the base is not necessarily the shape that the figure is sitting on. And the one that is really the tricky one is this first one that I gave you, actually, the triangular prism. The base, even though it's not sitting on the triangle, the base is the triangle. And there's one in the back too that you can kind of see through. The bases are triangles. That's what gives this figure its name as a triangular prism. So we are going to use the triangles as the base, even though they're not sitting on the base. It's sitting on one of the faces, which doesn't change that the bases are these triangles. So that's something to look out for, is the base is the shape that gives the solid figure its name, its specific name, so triangular prism. We can obviously tell pretty easily it's a prism versus a pyramid, okay, but the specific name, the triangular prism, is we get that from naming its base, the triangular prism. And here are the other ones too. There's a few extra on here that I didn't ask for. You can see a five-sided shape is a pentagonal prism that has 5 sides on the base and 5 faces. A hexagonal prism has 6 sides around its base and 6 faces. And an octagonal prism, an octagon, has 8 sides, so there's 8 faces going around. Same with the pyramids. With the pentagonal, the hexagonal, and the octagonal pyramids, the only difference is that, like we said, they only have one base and their faces are triangles so that they can meet at a point at the top. So let's compare the difference between prisms and pyramids. We've talked already about some of these differences, but let's write those down in our notes. So prisms have two bases. Pyramids only have one base. Prism's bases can be any polygon, and same with the pyramid's base, it can be any polygon. Remember, a polygon is simply a closed figure with any number of straight sides. And for a prism, its faces are rectangles, and a pyramid's faces are triangles. So those are the major differences between prisms and pyramids. Now we're going to look at the cross-section of these solid figures. And what I mean by a cross-section is, if you've ever played either of these games, Fruit Ninja or Wii Speed Slice, that's what we're talking about when we're saying cross-section. Basically, you take a three-dimensional figure and you slice it in one way or another, and the two-dimensional shape that results from the slice is the cross-section. So let's take a look. I have a little video that I would like to show you.
Shorts. Slicing solid, three-dimensional figures results in different two-dimensional shapes, depending on how you slice them. If you cut through a cylinder with a geometric plane parallel to the cylinder's base, the two-dimensional cross-section is a circle. Any way you slice it, you can get two-dimensional shapes from three-dimensional figures. When you slice a cylinder from top to bottom that is perpendicular to its base, then look at the cross-section straight on. You get a rectangle. What happens when you slice a square pyramid? If you slice across the pyramid with your plane parallel to the pyramid's base, the cross-section is a square. If you slice through your plane perpendicular to the pyramid's base, the cross-section is a triangle. Remember, you're slicing a solid, three-dimensional figure with a geometric plane. You can slice in any direction. Just keep in mind that shapes can look different when you look at them from different angles. So orient the cross-section on the geometric plane. Slicing diagonally can produce different shapes, such as an ellipse or a trapezoid. Understanding the two-dimensional shapes that result from slicing solid, three-dimensional figures is important for geometry and ninjas.
Okay, so they used a few specific terms in that video that we are going to need to pay close attention to, and that is specifically parallel and perpendicular to the base of the figure. So let's just take a look here. When we are saying that something is being sliced parallel to the base, that means that it is not going through the base. So we need to make sure, A, we can identify what the base of the figure is first, and then slice it parallel to that. So what's really tricky here is that, as I mentioned previously, the base is not always necessarily what the shape is sitting on. So for this first example, I have it right now sitting on its base. But I could tip it over and lay it on its side. If I tip it over and lay it on its side, the base is still the triangle, and therefore when I slice it parallel to the base, now my slice is going to be a vertical slice, versus if I have it standing up on its base, it's a horizontal slice from side to side. So we need to be careful that we're not just looking vertical versus horizontal. We need to look at where's the base and how can I slice parallel to that base, basically like through the middle here without cutting through the base. So when we slice a prism or a pyramid parallel to its base, we are going to get, for the prism, a cross-section that is the same shape and the exact same size as the base of that prism. You can see it is highlighted in green there. That is the cross section if I slice parallel to the base. With the pyramid, however, it is a slightly different size. It gets smaller as we get closer to the top of the pyramid because it meets at a point. So you'll see it's the same shape as the base. And I'm not outlining this very well, but it's the same shape. It's a rectangle, this rectangular pyramid. It's still a rectangle, but you can see it's much smaller. As we get closer to the top, it gets smaller and smaller. Now, it is going to be proportional in size, which means the ratio of the side lengths will be the same as it gets smaller. So if this is 4 and this is 8, as it gets smaller, it's going to stay that same ratio of 4 to 8. So maybe now it's 2 to 4. Or even closer to the top, it could be 1 to 2. So that stays proportional, but it does get smaller. If I slice my figures perpendicular to the base, that is going to cut through the base. So again, like I said in the previous one, we have to be careful because the base is not always just the top and the bottom. We have to make sure we're paying attention to how the figure is sitting, whether or not it's sitting on its base. So if it's sitting on its base, then perpendicular to the base is going to be straight up and down. But if it's not sitting on its base, if it's sitting on its side or one of its faces, then perpendicular is going to be up and down. So you have to be very careful, or side to side. You have to be very careful to identify what the base is, where it is, and then for perpendicular slice, if you remember, perpendicular means it cuts through at a 90-degree angle. So it's going to cut through that base. It's cutting through this triangular base, straight up and down at a 90-degree angle. So you can see it slicing at a 90-degree angle. That's straight up and down. That is going to result in a rectangle no matter what prism you're slicing. So not just this triangular prism, it's going to be a rectangle for any prism because the faces of a prism are all rectangles. And for the pyramid, you're always going to get a triangle since the faces of a pyramid are triangles. So again, that is perpendicular to the base. This is slicing straight through the tip, straight down at a 90-degree angle to the base. Okay, taking a look at these 4 examples, we'll call this A, B, C, and D. I want you to identify what each of these slices are. Is it parallel to the base or is it perpendicular to the base? So starting with shape A, okay, these directions say to sketch the cross section if the figure is sliced perpendicular to its base. Obviously, you can't sketch on here on the Edpuzzle, so I'm just going to give you a description of what shape it should be, and you're going to select the correct one. So we'll call this shape A, we'll call this triangular pyramid shape B, and we'll call this pentagonal prism shape C. And we're looking for the perpendicular slice, perpendicular to the base. Okay, now let's take a look at the same shapes, but let's slice them parallel to their base. Making sure we're very careful to identify what the base is first and then decide which direction the slice is going to go. For this cylinder, the base is the circle. So slicing parallel would go this way, resulting in a circle. For this triangular pyramid, the base is the triangle on the bottom, so slicing parallel would go horizontal side to side, which would result in a triangle. And for our shape C, this is our pentagonal prism. The pentagon is the base, So our slice is going to go straight up and down through the center of the prism, resulting in a pentagon that looks just like that base. So remember, identify what the base is first, and then you can determine what way to slice it, parallel and perpendicular.